It's a great pleasure to part of another Mobility Field Day. And we have a great session ahead of us, and I'm really looking forward to a really interactive conversation. So first, a quick reminder, in case you want to catch our first performance from last year, Mobility Field Day, please check out this website, celona.io/MFD4 to access the video recording. All right, so let's get to our presentation today. As most of you know, at Celona, our goal is to make LTE and 5G technologies accessible to enterprise IT and to allow them really accelerate adoption of business critical applications for mobile devices. So the availability of a clean spectrum, such as CBRS, is really a key enabler for this goal. And we have CBRS commercial now, but this is not sufficient. Our goal from technology perspective is really to leverage AI and cloud native software to remove any friction in the enterprises. We've been in this journey at Celona for about 18 months now and have been talking to many people in the field during this time. So far, everything we have seen and heard further confirms our conviction to private LTE 5G with cloud native software defined network and AI powered automation. So our customers are really looking for many applications to run in their networks that require high reliability and predictability. And as well as network professionals, we really need to stop making excuses for reliability and build a network that meets these requirements. So there are really three components to our approach that we call the new principles of enterprise wireless. So if you start from the bottom of this slide, step one is the network infrastructure. We picked the LTE and 5G technologies as the best of breed to develop our solution on top of the CBRS spectrum. The key aspects to highlight here is that we provide a complete end-to-end solution as an overlay to enterprise network that's easy to deploy, integrate, and operate. And this is crucial for ensuring the end-to-end reliability and quality of service for all these different applications and services. So current vendors with LTE cellular solutions in the market are mostly selling individual components and leaving the burden of integration to somebody else. And in our network infrastructure solution, our model is very different. We have a similar deployment model as Wi-Fi, but it comes with all the benefits of LTE and 5G. So the second critical aspect is how do you lower the total cost of ownership for such a sophisticated technology as LTE and 5G, right? So enterprise software has been adapting, as we all know, to a software as a service model and heavily leveraging cloud for many years now. The question is, how do you ensure that, with the privacy, security, and latency requirements that's driving the need for local services, how do you ensure that you have a solution that's flexible enough to meet all the needs of these services at a low cost point that's attractive at enterprises? So for this challenge, our answer is really cloud native software implementation. And our solution is based on microservice architecture that we'll go into more details that can run virtually on any platform, which brings all the benefits of cloud native software, such as full scalability, redundancy, resiliency. And we are essentially working with every edge platform out there, including hybrid cloud solutions. Third, and very crucial aspect of our solution is the AI-powered automation, and this term is used very heavily. So I want to be really clear in terms of what we do. If you think about it, most of these applications that I referred to require a very high level of reliability, predictability, very low latency, and LTE together with the LTE 5G together with CBRS band bring a lot of these technology benefits. However, all of these applications that enterprises may want to run has different requirements. Some require very high bandwidth, some require ultra low latency, some require ultra high reliability. So you cannot get into manual process of creating configurations and reference design for each of these applications. That will totally slow down the business way too much. So you have to introduce policy-based automation, and you need to let these networks adapt to the new applications as they emerge over the coming years. So our solution is designed from ground up based on providing an automated solution for the enterprise IT. All right, so hopefully this set of principles makes sense. Let's get into more details of these components. First of all, let's cover the benefits of LTE and 5G, right? We have to ask that question. What does private LTE 5G add to an enterprise network beyond Wi-Fi? So before going into these details, a quick explanation of the terminology. Private LTE 5G means we have a network deployed and operated as a private network by the enterprise, which is very different than traditional public macrocellular networks with wide area coverage. So private LTE 5G gives full control and visibility to the enterprise IT for the operation of the network. Then let's break this down into the benefits of LTE 5G into multiple aspects. First, LTE 5G comes with interference-free spectrum, which is locally available in the private LTE 5G case. So the analogy we give for this is, if you think about the traffic in an enterprise as a enterprise network as a highway, this is almost like having an HOV lane on that highway for certain traffic. For example, CBRS provides 150 megahertz of dedicated clean spectrum. And of course, everybody loves more spectrum, especially clean spectrum with no interference. So we automate the spectrum management, and the whole operation depends, everything we do in the background, no manual intervention needed from the end customer. Secondly, the security has always been a key feature of LTE from the start. And this further extends to 5G, of course. And SIM-based authentication provides ability for device-level access control with either physical SIM or electronic SIM in the devices. And we make the remote provisioning of SIMs very easy. This enables enterprises with device-level access control in a seamless way. And thirdly, the most crucial aspect, of course, of LTE 5G is the reliability and ability to achieve this high level of service level objectives for different applications. And this is achieved by not only the dedicated local spectrum used by the networks such as CBRS, but also OFDMA-based QoS scheduler, which has been in the field for more than a decade now, right? Essentially, the LTE and 5G APs assign certain frequency tones to certain users very dynamically. For example, at a given time instance of every millisecond, the APs can schedule traffic simultaneously to users and devices to satisfy their needs of the applications. This means that many users can be scheduled simultaneously instead of one user at a time, and no one can hog the resources. And it also means that the access and control data are handled as specific channels as frequency tones. As a result, there's no interrupt to the transmission of data to all the users, and an end result is a very good quality, predictability, and guaranteed quality of service as required by these applications. The other aspect is that all these mobile devices are very tightly controlled by the network infrastructure, and this ensures the whole operation is carefully orchestrated. As a result, we can achieve seamless mobility and roaming, no packet loss during those mobility events, and you can achieve very tight deterministic QoS for all these applications. And lastly, the whole private LTE 5G solution can essentially be deployed as an app on the edge. And this is exactly what we achieve with our cloud-native software implementation, right? Our solution, as I said, fits perfectly to the edge cloud solutions by many cloud providers, but also telcos can take our solution as part of their MEC solution. So as I said, we have been on this journey for a while now, and for about 9 months, we have been in field deployments with real use cases. And that spans multiple verticals, but I can summarize these real-world use cases which drive this initial adaptation of the technology into basically 3 categories. First is really outdoor, long-range applications for devices requiring connectivity in these environments, such as yards or ports or campuses or parking lots. And the second one is mainly real-time media applications, such as voice over IP or video telephony, or even computer vision-based applications driven by IP cameras. And the third set of applications evolve around creating partition for the whole employee and IoT devices in an enterprise for their private devices, which is separated from the guest Wi-Fi. So this is one way to partition those more business critical applications. And here I'm showing some example verticals with some specific examples. For example, in healthcare, logistics, and enterprise, you see a lot of employee handheld devices that varies from iPhones to Zebras to Samsung devices. There's also lots of IoT examples in transportation or education for outdoor cameras and so forth, where you see Sierra Wireless or Cradlepoint gateways and so forth. If there are no questions or comments, I'm going to move into some of the solution architecture, and we can get a little bit more technical. And of course, the main question is, isn't LTE and 5G complicated technology? How can you make it simple to deploy and operate? And how can you provide all the key benefits of 5G in an enterprise environment? So for that, we have been hard at work to bring our integrated end-to-end solution to market. And the very first point that I want to highlight is that we provide essentially a one-stop shop infrastructure solution. There are really four main components to our solution. Firstly, we provide the radio network, radio access network, as we call RAN, which is essentially a collection of LTE 5G access points. And we provide both indoor and outdoor APs. And these are plug and play, and they cover a variety of use cases in all kinds of enterprise environments. So these 4G and 5G access points connect the Celona Edge over the local enterprise network. And Celona Edge is a complete software solution, which is essentially a cloud-native service plane. And both Celona Edge and Celona RAN and all the SIM-activated devices are configured by the cloud-hosted Celona orchestrator, which is essentially the brains of the whole network that's powered by AI. And lastly, we provide SIMs for the end devices, either as physical SIMs or electronic SIMs, eSIMs. So our customers can provision these SIMs remotely using our own device management services. So essentially at the end, our customers plug the APs to the local Ethernet, and then they can download the Celona Edge software. And then they log into the Celona orchestrator, activate the network in the mobile devices, and then in a matter of minutes, this overlay network is up and running. So let's go into some real actual network deployment scenarios, right? How does it look in an actual enterprise network? As I said, it's a complete plug and play solution at the level of simplicity that the enterprise demands. And here I'm going into specific components of it. The whole aim from start has been simplicity, right? And we thought long and hard about each component of the solution to enable the deployment as an overlay to existing enterprise network. This is really fundamentally different than the traditional 4G, 5G small cell deployments, which are typically deployed as more isolated network from the enterprise network. In this picture, you see these three Celona solution components as blue boxes. On the left, you see the Celona access points that are PoE enabled. They plug directly into the enterprise LAN. And in the middle, you see the Celona Edge that can run on any x86 hardware platform in enterprise environments, such as VM platforms or servers. And it's typically deployed as close to business critical applications as possible to improve the performance metrics and reliability. And the Celona Edge integrates with the existing network services on premise within the campus or branch, adapting to existing configurations and the policies. And lastly here, you see the Celona orchestrator, which provides a single console network management and monitoring, and the whole infrastructure can be deployed as an overlay, as I mentioned. In this specific example, you see the Celona Edge deployed in a distributed manner on the premises. And alternatively, the Celona Edge can be deployed as a centralized node. And here we show the case where Celona Edge is deployed as central location in a public or private cloud. And this model may be more suitable for use cases with branch or remote offices where most applications are run in a central server. So typically, it makes most sense to deploy the Celona Edge close to where the enterprise applications are. But the bottom line is the Celona is a very flexible platform. It can run either on-prem or cloud, and it can pretty much run on any hardware platform, as I mentioned earlier. Here's a look at some of the more details, as I always says, peeling the onion kind of thing. So there's lots of innovative technology and detailed engineering work that went into the solution, right? So instead of trying to adapt an existing metro network solution from MNO space, we have developed the full solution from ground up for the enterprise space. On the RAN, we translate dynamic spectrum requirements obtained via spectrum access systems for the CBRS spectrum. The application level SLA requirements are translated into RAN slicing and the LTE 5G QoS scheduler implementation. And these radios run as a self-organizing radio layer to ensure the frequency assignments, the radio power levels, and relevant capacity coverage is really adequately optimized by these self-organizing networks features. On the edge, to simplify and scale the enterprise deployment and to ensure the reservation of the data paid compute and memory resources for all the right applications and device groups, all functions are deployed as microservices and they can scale horizontally. We use Kubernetes framework for all of our microservices. And on the orchestrator, the microslice level visibility, the network automation depends on continuous learning of all the parameters across different deployments, apps, device types, RAN metrics, and that also extend to the planning and dimensioning of the network.
Mehmet, I had a question. Last year when we met, you were not owning the RAN part. You weren't making your own access points. Is that a change in your business model?
Just to be very clear, we own the full RAN in our solution. It's a complete end-to-end solution. And what we have on the RAN is, of course, there is the, right now, LTE small cell solution, right? But our real differentiation comes in with the QoS scheduler implementation and the integration of the RAN to the rest of the network as a plug-and-play solution and PoE Plus solution. So it's really part of our complete solution package, Keith.
This is Rajiv here, just maybe seconding that, Keith. I think last time when we spoke last year, some of the ideas were the same, but over the last 12 months, if there's a realization we have had is the actual software at the lowest layers on that LTE access point is still a massive area for innovation to truly get this. And so I think we have embraced that a little bit more. And we have now said, hey, we need to go do that. And there is a lot more that we can do by owning that.
So can you go a little bit further? And I know very little about CBRS, but can you go into a little bit more detail? And forgive me if this has already been mentioned, and Keith's already shared some information for me to check into more. But can you explain to me and others out there that don't know, is this like a replacement for Wi-Fi, or is this something, I know you said it's like an overlay, is this something you integrate with Wi-Fi? Is this indoor, outdoor? Can you get a little bit more granular with that, please?
Sure, of course. Great question. So first of all, CBRS is the band that we use, right? It's a totally separate spectrum band in 3.55 to 3.7. So it first of all gives this additional spectrum for the enterprise, right? It's different than the 2.4 or 5, it's 3.5. And then in this new spectrum, we have this technology, LTE, that operates as a wireless network for the enterprise. And it's really a complement to the Wi-Fi that works in 2.4 and 5 gigahertz and now like 6 gigahertz coming in the unlicensed band. This solution, CBRS LTE, is a separate solution that works in 3.5. It uses the same LAN and the switches and all the infrastructure in the enterprise. And it really brings additional use cases and capabilities for the mobile devices. So it's like a complementary solution you can think, and it integrates with the enterprise network just like Wi-Fi integrates. So this is another wireless network that integrates with the backend and the IP and the policy and everything that's in place.
So this is like just it's almost like adding just another band so you have more capacity. Is that the idea?
Yeah, you have more capacity, but also you have more predictability, better range, more coverage. So all the places where you may be struggling with Wi-Fi, now you have this solution that gives you that additional benefits. Again, better range, better predictability. So if you have applications such as VoIP or conversational video or some applications that require higher reliability with low latency in IoT use cases, for all of those applications, those devices can use this network.
Okay, so and forgive me for hijacking this a little bit, but so I have a specific use case right now where we need to get network ability out in the outdoors for obvious reasons, right? So a lot of our schools need to have some coverage, for example, at our high school parking lots. And we're leveraging cradle points right now, and then potentially tunneling that traffic back through a VPN tunnel to connect to our network. So, something pretty simple. It's a little bit more detailed than that. But is this like, could CBRS be a good solution to that?
Absolutely, absolutely. I mean, you picked a very typical example, frankly, where you would like to get coverage in the parking lots or in the extended region, right, around the enterprise. And usually what we see is Wi-Fi really struggles with providing that coverage in a reliable way. And if you want to run some wireline, it's very costly with the trenches and so forth. Instead, what you can do is you can put a few CBRS private LTE base stations, APs, to cover a large area. And there are a lot of devices such as Cradle Point that supports this technology, and they can connect to this network wherever that end devices need to be, right, in that large coverage area.
Thank you for that. I'm going to need to talk to you guys a little bit more. This is some good stuff, and I appreciate you just kind of breaking it down on a fundamental level for me.
Absolutely, absolutely. Love to continue conversation on that.
Yeah, I might jump in real quick. I think, coming from a Wi-Fi background, some of the differences you can look at are control of the spectrum. So some of the reliability and predictability that Mehmet is talking about comes into play because LTE and 5G as protocols from the MAC layer, they control the scheduling, both downlink and uplink from clients. So when we get into the quality of service and the service level objectives for mission critical applications, you can view CBRS and LTE from a private networking perspective as that HOV lane where it's mission critical applications that need to have kind of their own dedicated lane on the enterprise network, not competing with traffic from everybody else. So it's very complementary to Wi-Fi where you should leave, a lot of your generic employee productivity and guest networking use cases with Wi-Fi, and then have this express lane for those mission critical applications that require those higher level guarantees or that may be a little bit more sensitive to hiccups in a wireless network. So it's another access method onto an enterprise network, and one that offers just unique, different performance characteristics than you may be familiar with Wi-Fi. So yes, there's spectrum differences in the amount of spectrum, but that's from a very raw physical layer. And a lot of the benefits here come in at the protocol and the MAC layer about how that traffic is handled, how it's scheduled, and what you can do with that for quality of service and for device density handling, and then the larger range as well.
Can I ask a question about your edge, please? I noticed that most of the functions you've got, well, all the functions you've got listed there are 4G functions. As we go forward and you migrate this to 5G, and 5G being a RESTful architecture, HTTP2, interfaces between all the functions, is this platform, I see you've already got micro slices there, so is this platform, although it's 4G, kind of enabled and ready to transition to the 4G architecture in the core network?
Yeah, great question, Emerald. And actually, this our bad. This is the old version of the slide. We have 5G core functions are already implemented. But the big question is not the specific escape, UPF, AMF, those functions. The big question is the implementation is totally what 5G has been envisioning. Mm-hmm. And the way we do this is using cloud native software, right? All of these functions, AMF, UPF, network section, and all of these different components are really broken into microservices in our implementation. Mm. So it is full microservices implementation, stateless implementation, and we'll get into some more details of this. And that's already in place. That's our commercial offering that is already out. And the 5G core part is also pre-integrated to this, but that will require the 5G RAN and the 5G devices to come, right? Mm-hmm. But the implementation is totally, fully what 5G has been envisioning. And we're really very proud of our implementation today because it really achieves all the things that has been envisioned and more in terms of integration with the enterprise.
One last comment then, if you have time when you do your presentation to talk about the application function and whether that exists in your network, that might be very relevant to Mitchell's question a little bit earlier.
Yeah, we definitely do. And I would love to go into some more details of it in the later part.
Yeah, if you have time. Thanks.
Perfect.
Great.
Thanks, Evan.
Hey, Mehmet, while we're doing questions, there's also some questions coming in on Twitter, including what are some of the examples of endpoint devices that are already CBRS ready? If you could add that in while you're going.
Oh, thanks, Jen. A lot of devices out there, and I know I won't be able to list all of them. We have our website that has a reference to it, so if some of the folks can get the exact URL meanwhile, that'll be great. The set of devices vary from the handhelds to a lot of IoT devices. On the handheld side, just to list a few, iPhone 11, iPhone SE, iPad Pro, pretty much all the Samsung Galaxy S10 variants and, Pixels, and pretty much all the devices on that side are now coming with the CBRS support because operators are also mandating to support this band. But also on the IoT side, right, there's a lot of IoT gateways, Ethernet bridges, dongles that are coming in and already commercial out there. And also there are lots of more industrial ruggedized handhelds and scanners that's also out there. So the bottom line is this band is a mainstream band now for 5G as well. So all the chipsets are coming with the support of this band. And it's a matter of really all these devices coming to the ecosystem. And we have been seeing this for more than a year. And again, on our website, we have a reference for this.
So a real quick question, one of the concerns that obviously comes up when we start talking about a different band is RF planning for coverage and that type of thing. Not taking anything away from IB Wave, which obviously is capable of doing this, but that's not what your traditional Wi-Fi person uses a lot of times. Has there been any advancement on that front for RF planning especially when we start talking about inside buildings and warehouses and things that might have a little bit more complex RF environment?
Yeah. And I mean, Andrew, that's your expertise too. So if you want to.
Yeah. From a field deployment perspective, one thing I'll highlight is that proper planning and design is still critical for deployment of a network. We typically tell everyone to start with a rough order of magnitude estimate using our Celona network planner, which is free on our website at planner.celona.io. And you can put in a location and see what spectrum is available and do a rough estimate for a given indoor or outdoor scenario for coverage area, as well as devices and bandwidth requirements to understand how many APs are required to meet those needs. And that's, upfront in a project from a planning perspective for budgetary assessment. Once the rubber meets the road and the project gets greenlit or you start moving forward and need to do a more detailed design, that's where we're working with our partners in the industry for the more predictive modeling software to upload floor plans, deploy APs on those floor plans, and model the coverage, the signal to interference and noise ratio, and the capacity requirements. And that comes in with partners like IBWave out there in the industry that have those software solutions that we're partnering with. And they also have solutions for the post-deployment RF site survey or walk test to validate that the signal and the quality is there post-deployment as well. So yeah, through each of those phases, we recommend that proper design is still done.
Yeah, and we had a webinar with IBWave folks very recently, so this are on our website as well. That gets into some further details for everyone watching.
Just to give us a quick sense of, in a CBRS cell versus like a Wi-Fi cell, just typical, if there is such a thing in either case, client density supported. Just
I'll start, and Andrew, you feel free to jump in. With our solution per AP, we can get the numbers such as 96 or 128 right now on LTE, and this is simultaneously connected devices, right? Every device simultaneously transmitting data. And in addition to that, I mean, LTE and both LTE and 5G has this concept of idle, where if a device doesn't have any data for a few seconds, you can quickly put those devices in the idle state. And when there's a data coming in, the device quickly can get into so-called connected active state. So that way you can really have hundreds of devices, and at any given time you will have maybe about 100 devices actively transmitting data. So that's significantly more than what we typically get with Wi-Fi. And Andrew, Rajiv, if you want to give some numbers on the Wi-Fi side, maybe for comparison.
Yeah, I mean, there's been rules of thumb and discussion around Wi-Fi client density for a long time. A lot of people don't like to have more than somewhere between 50 to 30 clients on a Wi-Fi radio, depending on the application or their airtime utilization or demand on the network. And it also comes into play whether or not they're passing real-time traffic like voice or not. So I think we do see somewhat of a multiple of that on LTE, especially given the ability to offload those client connections if they're in the idle state back to the packet core. So that frees up radio resources to handle the active clients that are passing traffic at that second. So quite a different paradigm, I would say. And that becomes very useful, especially for very high density IoT type deployments or very high density like large public venues where you have those client densities, whether it's IoT sensors or mobile devices that all need to connect to the network at once.
Yeah, so that's kind of what I was, that's kind of why I was asking. I'm thinking, stadiums and the horrible challenges of doing good Wi-Fi in stadiums and thinking, boy, wouldn't it be nice to have an alternative? And is this it kind of thing? You know what I mean?
Yeah, absolutely.
So one of the challenges that I think we've seen in the Wi-Fi space traditionally is that we have to deal with such a thing as too many APs, where we have multiple APs on the same channel, obviously don't get extra capacity. Is that big of a deal in a CBRS world, or is that something that is different or that we can have other considerations for?
Yeah, great point, Sam. And I'll jump in there. I mean, the basic thing to think about is LTE and 5G can operate on the same channel. The APs are capable of operating on the same channel, and that's called universal frequency reuse. Right? So if you get to a high density scenario, you don't need to do the channel planning. All of that we do on the back end to simplify the deployment and so forth. But what it comes down to is between these APs, you don't need to have detailed channel planning because they are capable of working on the same channel. The issue with Wi-Fi is really goes back to the CSMA aspect, right? As you folks know very well. And when the device is active, it essentially shuts down a bunch of other STs or APs in the neighborhood because it's just one device at a time. And that becomes really problematic as you increase the density of the APs and you need to carefully plan the channels and so forth. That really goes away with LTE and 5G.
Yeah, and I'll jump in a little bit there and add that comes in because of the interference coordination capabilities on LTE. So multiple LTE access points can schedule transmissions across the time domain on a single channel and coexist, as well as then if the network density becomes high enough, they can actually schedule transmissions at the same time, and those can coexist, but they slightly raise the noise floor for one another. But those transmissions can still go out in parallel at the same time. So you don't have this complete back off nature from a protocol perspective like you do with Wi-Fi. You can layer in more LTE access points and layer in additional capacity as long as you do it in a smart fashion, and they can exist on the same channel to a large degree.
Yeah. And basically as that noise floor increases, what happens is the data rates go down because there's a very tight control loop adjusting the packet sizes on the Airlink to make sure just the right amount of data packets are sent to enable proper reception at the receiver in that noise floor level. It's not like a binary decision like in Wi-Fi, in other words.